You're talking to a chatbot, it sounds confident, it sounds smart, but is it telling you the truth, or is it just making things up? It's a massive problem in AI. But what if you could peek inside the AI's mind while it's thinking and see the exact moment it decides to go off the rails? Well, that's what we're going to dig into today, a wild new method that's trying to do just that.
I mean, it sounds like something straight out of science fiction, doesn't it? Can we actually give an AI a polygraph test? Well, according to some new research, the answer is kinda, yeah. And it's a huge step toward building AI systems that we can finally actually trust.
The whole idea here is built on a really cool analogy. You know how a human lie detector works, right? It's looking for physical signs of stress, your heart rate jumping, your brain waves changing. Well, this new technique does the exact same thing, but for an AI. It's not looking for a heartbeat, obviously, but it's measuring the AI's internal signals, the patterns firing deep inside its neural network, to see if it can spot any weirdness in its thinking.
Now, to really get why this is such a big deal, we need to talk about the problem they're trying to solve. And in the AI world, this problem has a very specific and kind of spooky name: hallucination.
So what exactly is an AI hallucination? Well, it's basically when a large language model, or LLM, just confidently invents an answer. It sounds totally plausible, but it's completely wrong. It's a made-up fact, a bogus quote, something with zero basis in reality.
The researchers who wrote the paper put it really simply. They say it's the production of results that are factually inconsistent or lack contextual support. This isn't just some small bug in the system. It's a fundamental flaw we're trying to engineer our way out of.
And, why should you care? Because every time an AI hallucinates, it chips away at our trust. It's the #1 thing holding us back from using these powerful tools in really important fields like medicine or law or finance. Seriously, solving this is one of the biggest challenges on the path to building reliable AI.
So, how do we start to fix it? Well, this new idea is really interesting because it's inspired by the way we study the human brain itself, specifically how we try to detect when a person is being deceptive. The method's called HSAD. It stands for Hidden Signal Analysis-Based Detection. And the key difference here is that instead of trying to fact-check an AI's answer by scouring the internet, HSAD looks for the evidence of the lie inside the AI itself. So how does it listen in? Okay, so as the AI is building its answer word by word, or token by token, HSAD is basically like an EEG for the model's brain. It's recording all the internal chatter from every single layer. Then, it stitches all that data together into one long timeline, a complete recording of the AI's train of thought.
All right, so now we have this incredibly complicated signal, this recording of the AI's internal monologue. Now for the really hard part. How do you find the tiny little fingerprint of a lie that's buried in all that noise?
And that's really the million-dollar question, isn't it? How on earth do you spot one tiny little blip in a signal that represents the inner workings of a massive AI with billions of moving parts? Well, the answer comes from this really powerful math tool that's been around for a long time in signal processing. It's called the Fast Fourier Transform, or FFT for short.
The best way to get your head around FFT is to think of a prism. You know how a prism takes a beam of plain white light and breaks it apart into all the colors of the rainbow? Well, FFT does the same thing for signals. It takes that messy, complex brainwave from the AI and breaks it down into all its simple core frequencies. And suddenly, it's way easier to see if something's out of place.
And this is where they found the smoking gun. It turns out that when an AI is telling the truth, its frequency signal is pretty smooth, pretty consistent. But when it hallucinates, there's a sudden sharp spike in the signal. It's like a digital nervous tick, a tell that gives away the fact that it's making something up.
Okay, so this all sounds amazing in theory. But the big question is, does this AI polygraph actually work in the real world? Well, the researchers put HSAD head-to-head with all the other top methods. And honestly, the results are pretty darn good.
And the big headline number is this. Across a bunch of standard tests, HSAD was over 10% better on average than the previous best methods. Now, in the world of AI research, a 10-point jump is a really big leap forward.
So let's look at one of the main tests, a dataset called Truthful QA. The old state-of-the-art, a method called Haloscope, was already a huge improvement over the baseline. But as you can see, HSA just inches past it, setting a new record for performance. It's a tough problem, so even a small gain like this is a really big win.
What's also cool is that the research uncovered some other fascinating little details. For instance, if you're going to tap into the AI's thought process,
Where's the best place to listen in to catch it in a lie? And the answer is pretty surprising, actually. That weird signal, the tell that it's hallucinating, is strongest at the very end of its answer. It's almost like the AI goes through the whole process of making something up, and the mental strain of doing that really shows up right as it's finishing its thought. Okay, so another big question is about efficiency. Do you have to monitor the entire massive AI model, or can you just get away with listening to a few key parts?
Turns out, you need to listen to the whole shebang. The method is way more accurate when it's sampling signals from every single layer of the model. And that suggests that a hallucination isn't just some small local glitch. It's more like a system-wide failure in the AI's ability to reason.
So let's zoom out and put this all together. What does a new technique like HSAD really mean for the future of AI? So, if you're going to take away a few key things, here they are. First, we now know we can spot these hallucinations just by analyzing the AI's internal process. Second, and this is a real game changer, this whole thing works without having to constantly check against the outside world, which has always been a huge pain. And finally, this is more than just a lie detector. It's a new window into how these things actually think, which gets us a step closer to maybe controlling them.
And that all leads to one final huge question. You see, being able to detect a lie is the first step. But if we can get really good at knowing when an AI is about to lie, what's next? Can we actually step in? Can we use that signal to stop the lie before it ever gets written, and maybe even guide the AI toward an answer that is actually, truly honest? That, right there, is the challenge this research leaves us with.